Our next presentation comes from Milo Krasojevic. I'm sorry, Krasojevic. Is it a duo? We're doing the duo. Okay. And Tomas Milshavsky from Supermicro. This is our last sponsor presentation. Thank you all, the sponsors, for sponsoring this workshop. It means a lot to us.
Hello, everyone. Hello. Thank you very much for inviting us to present today. I'm really happy that all of you, or almost all of you, stayed after the lunch. Let me introduce ourselves. My name is Tomasz Mieszkowski. I'm a solution architect for Supermicro, working in the company for the last 7 years, but having an experience with Supermicro stuff for the last 15 at least. We have today also Milos Krasojevic, who is manager of product management for GPU systems. We have also our sales team together with us. We have Halina Maivka, our senior sales manager, and Alexander Velimirovich, senior director of sales. All of us are in fact facing the customer, so we are working for the technical part of the stuff. Our sales team is working for the logistics, cooperation with partners, and all of us in fact are selling Supermicro systems. As this is our first presentation at HPC AI Advisory Council, we decided to give a short shot of information about the Supermicro itself, and then we will switch to the more technical part, describing how we are doing on the market, what will come next, and what will be new for our customers. I have a question. Do you know anything about Supermicro so far? So what Supermicro is doing? Okay, so I would like to change a little bit of perspective how you see Supermicro. Supermicro, in fact, right now is a global solution provider doing over 14 billion of revenue. We are finishing our financial year in June, so these are just approximate numbers, could be better. Our headquarters is located in Silicon Valley. See the first day of operation of Supermicro. We have the headquarters in EMEA region, located in Netherlands. We have also 2 sites in Asia. This is the office, the campus, in fact, in Taiwan, and the new one in Malaysia. The number of the systems we are doing yearly is exceeding at the moment 1.4 million of units annually. This is the data from 2022. And yes, we are benefiting a lot from AI hype and the growing interest in AI systems and GPU systems in general. Just to give you a colorful example, when I was starting working for Supermicro, the market value of the company was 10 times lower than the leader of the market. Right now, to the leader of the market, in terms of value of the company, we are losing like 20–25%. And the companies which are after us, their value is at least 2 times lower than the value of Supermicro today. As the demand for the system is growing, we are of course expanding pretty rapidly. And of course, except the expansion of the sites we have right now, we are planning also to open new sites in Silicon Valley location, the new sites in Netherlands, and also we are planning new sites in Mexico and Texas. And a little bit of our portfolio. The idea of Supermicro is to create very optimized systems for different use cases, different workloads, without using proprietary technology and trying to keep as most standard as it is only possible. So you may have a system which will be dedicated to work with most TDP intensive components, so whatever is best, which will be optimized from the thermal and performance point of view. You can have the system which will be optimized for cost, or optimized for storage, or optimized for AI, or for intensive load, or optimized for edge IoT, etc., etc. The amount of systems we are offering right now is more than 650 different kind of SKUs. So this gives you a full set of Lego blocks you can build, mix and match all together, creating the full environment.
Yeah, this is what we call building block solution.
Yeah,
Because
exactly.
you can just take apart, put together, and then you have the optimized system for yourself.
But building blocks is not everything. What we are going to do right now is to focus on rack scale level solutions. So we do not want to be server-centric, but more solution-centric. So the goal is to give you the opportunity to acquire fully assembled rack systems in plug-and-play scenario, which will have the hardware you need, networking you need, and software stack you need as a solution. We are always excelling in being green. It means that we take care about energy efficiency, about TCO. So a lot of components we are using in the systems are in fact interchangeable between different kinds of solutions. This gives us the opportunity to save a lot of costs in the big scale implementations. Also, we put a lot of efforts in business automation, so we automated a lot of our internal processes, but also processes which are facing our customers, just to make it easier. And definitely we won't stop there. There is a lot of new things to come, which will bring Supermicro in totally another place. Just to give you an overview how the split looks right now. Of course, fully assembled systems are still, this is this blue part, yeah? Assembled systems are still pretty important part of our business. But when we will look at the scale and development of rack level solutions, this is the light green, it will be the majority of business in Supermicro pretty soon. In our case, this is delivering, as I said, the mix of stuff you need. So computing, networking, storage, also software stack, taking the full responsibility for the solution, full processes like burn-in, testing, etc., and delivering the goods to the customer in plug-and-play scenario, just to save time, money. And the current capacity we have, this is the data actual till the half of the year, most probably, is 5,000 racks per month. Till the end of the year, this number will be doubled. I think that right now is a good time to give the time to Milos. He will say a little bit about what's coming next and how we are going to improve our services.
Yeah, so can I get the next slide, please? So the thing is, if you can see from the slides here, the power consumption on the GPU is going up, and currently NVIDIA has a GPU which consumes 700 watt. If you calculate this in the system where you can have up to 7 or 8 or 10 GPUs, then you are going very fast to 10 kilowatts. But this is just at the moment, till end of the year, this number will go much higher. Means you have actually some kind of problem in this sense that maybe you see for the portfolio in the past, you have a lot of 1 or 2 U system, which are disappearing because we are hitting limitation and we cannot cool them with the air anymore. So actually, if you can see from the slide also, the CPU power is also going pretty high. So we will have challenges because a lot of data center in Europe, at least, they are not ready for this amount of the system which we need to go in the data center. So actually, we will keep it as fast as possible, or actually as long as possible, still on the air cooled. But we need also to consider that we are also need to move on the liquid cooling stuff. So actually, you can see here from this slide that we are also trying to reduce the PU from 1.2 till 1.1, which we are really hard try to do this. And this is one of the reasons why Supermicro a few years ago decided to go with our own liquid cooling solution. So because we have enough in-house knowledge and we are developing this everything by ourselves. And this is more or less the challenging which we have today. So actually we have immense power which we need to use it. Then we need to cool it, and we need to have optimal solution to put everything together. So with the rack scale liquid cooling solution, we are trying to do this approach. Because I can tell you, so we are doing on some kind of large project which are over $1 billion, and the things are getting pretty complex. Because besides of the GPU system which you need to have optimized and very fast network. You need also to have very fast storage, and then you need to have proper cooling for everything. So if we are taking a part of the regular H100 ATU system, just in idle stage, they are consuming 2 kilowatt. So beside of that, so we try to modify and do modular solution for the liquid cooling. Means you can see from slide here that we are doing our old cold plates, how we are calling it. X13 means for by us for Intel, and H13 is AMD, and H100 is NVIDIA GPUs. So actually we are trying to cover the most components who are participated with the highest heat. And then you can also see for this kind of project, it's very important to see that by liquid cooling solution, we could not allow ourselves that we have any kind of leakage or any kind of problem, because this will be disaster in the data center. So actually we are also having the leaking detection sensor on our equipment, which can be monitored for the whole rack, or actually for the whole cluster. Besides the liquid cooling parts, we are also producing CDUs. So actually we have our own cooling distribution unit, and also we are also producing CDMs and also connectors. So actually you see we have full solution for every of our component which we are using into the rack integration.
We are still working on making it a little bit more complex, but it is still just business calculation. So if the market will need much more complex solution, having much higher efficiency in terms of taking the heat to the water, we will propose that. But frankly speaking, having pretty simple calculation, it is just economy of cost. Yeah, because we had a lot of presentations in the past days which were describing the cluster consuming like 5 megawatts of energy. Yeah? And if you are looking even at the very high costs of energy in Europe, where it is a pretty simple calculation. Yeah? If 1 megawatt per hour of energy is worth like 130, 140 euro, it means that having the cluster running for 24 hours per day, 365 days per year, and for 5 years, the full cost of running the cluster in terms of energy consumption would be like around 6 million euro. It means that having 5% difference for 5 years, it's not a huge amount of money. But to get higher in terms of energy efficiency, of taking this heat totally to water installation, is the cost, and the let's say implementation cost is much higher than the cost of the energy right now, even if the costs are on the very high level. it also, the idea of thinking about liquid cooling changed a lot, because at the very beginning of this, let's say, implementation of first liquid-cooled installations, at least my first liquid-cooled cluster was built in 2011, if I remember well. Then we were doing this to save the money, yeah? This is also connected to the European Union subsidies for education research institutes, which are given the money to buy the cluster, but operating the cluster is another way, yeah? So this was the way to save some budgets. Right now, investment into liquid-cooled solution is not to save the money, but to be able to operate the cluster. Because otherwise, with only air cooling systems, it will be or very, very expensive or simply impossible.
So to come to a conclusion, if I understood well, so liquid cooling, it makes sense only in case we have, let's say, a certain saving. Because to my understanding, based on your calculation, it just doesn't...
No. The liquid cooling itself, in my opinion, in my personal opinion, is a must to operate the cluster in the close future. But to make it more complex, it needs to be economically right.
Okay, so that's where, based on what we are going to see from a hardware point of view, liquid cooling is a must, because air cooling is becoming more and more difficult to implement.
The system would be bigger and bigger if you would like to stay with air cooling only.
Let me say, you will have 1,000 watt for the next GPU, even 1,500 watt per GPU. How you want to cool it in the future? I mean, now we are like on the edge, but I'm pretty sure in 1 or 2 years, this will be not possible if the GPU vendor continue to build the GPUs which are consuming an enormous power.
We're living in times of revolution. When we are looking at how the CPUs were evolving in the past, we had 8-10 years periods when we were going from 105 watt TDP to 135 watt TDP. It was taking a lot of time. Right now, in the last 4 years, 200, 300, right now 400, until the end of the year we are pretty sure it will be 500.
500 per CPU. So dual socket, kilowatt. Where is the rest?
Thank you.
Okay. So actually, I just want to show you how our high capacity CDU looks like. So this is actually also our own development. This is the very interesting device, because we realized in the past, if something goes wrong in the rack, you need to shut down the whole system. Now this day you don't need to do it. So actually you have here 3 screws. You can just do it everything by yourself. Swap the pump, put it back, and you don't need to change anything. So actually this is one of the features which is very interesting, that it's hot swappable pumps and of course power supplies.
Yes, this gives us the opportunity to be fully redundant inside one rack, because as we are looking at the competitive solutions, the most popular CDU on the market at the moment needs 2 CDUs to be redundant between itself.
Won't have any leak in case of changes on some of it, or you are you're going in the reverse, let's say, pumping?
Nope, we didn't observe such kind of situation. It's fully tested and proven. I think that the first CDU was used a few years ago at Osaka University, where we were building the cluster for something like 1,500 of nodes. So it's tested. It was this kind of CDU installation with the first steps of liquid cooling solution from Supermicro together with our blade systems.
So I just want to show you how the 8U or actually 800 GPU system looks like. So we reduce this because usually we have also the air-cooled version, which is 8U. 8U because the heatsink for NVIDIA is almost 3.5 U. So actually using the possibility to have liquid cool system, so we can shrink the system to 4U, and you have full capacity. I mean, it's the same like 8U, just that you have less more space. So the goal of this system is, for example, we have a rules if you want to purchase the H100 8U system air cooled, we are putting 4 system per rack. To increase the density, if you're going to liquid cooling, we can install up to 8 4U H100 system in one rack, plus the CDU, which I show you. So, and then, but you need to calculate around 100 kilowatt per rack if you're going liquid cooled. If you're going air cooled, around 40 kilowatt. So actually, this is the problem which I already tried to emphasize earlier, that we have challenge in the future, because if the GPU system are increasing the power consumption, you know, we have already some kind of order which we are preparing for the future development. So customer is already asking 300 to 500 kilowatts per rack. I mean, it's insane. So you need to have nuclear plants next to your data center to be able to run it. This is actually current situation which we are facing now. This is actually the ready system also for H200, which is coming June time frame roughly. So we just need to swap the GPU part, and we are ready to go. So we work very close with NVIDIA. So we are developing the stuff with them together. There is just one of these systems which I choose because the portfolio is pretty good.
We would need 4 hours to just roughly go model over model.
Yeah. So, but there is also another interesting approach which we calling MGX system, which is like Blackwell. We have also this in portfolio, and then you will see maybe the trend is changing for this huge system like we have it now. Then we are thinking that everything will goes in direction 1U, 2U, because as you know, Blackwell is like CPU, GPU, and memory together combined. It will change the whole strategy on the market. Also, in the new system, you will not see 2.5-inch drives anymore, because they will not be able to give you the performance very soon in the future, which we expect. And so actually we are moving for all this kind of new NVIDIA MGX system. We are moving to 1ES module, which is like M.2, but just for the server part. We cover most of the part now. So, but as we are working with a large deployment, so actually there is also additional question which we have for longer period of time. It's like, yeah, how I can manage 1,000 of the racks. So actually, we are still not longer the hardware company anymore. So actually, we start to develop software. In this case, we have also the department by us, which is deploying or actually developing the Super Cloud Composer. Super Cloud Composer you can mention in 2 different shapes. So one is to monitor and to maintain the hardware, and the second one is that you can have a possibility to orchestrate the whole cluster. So actually we are also working on several different cases for the AI. That means you just have the 1,000 racks, and with few clicks you can deploy the whole cluster what you need, and then you can change easily and switch it. So actually this is the main goal, to be able to give our customer complete solution, means not only the hardware part, then also the maintenance and also the orchestration together. And this is what Cloud Composer is doing now. It's still under the heavy development.
Yeah, this is in fact also a little bit different approach we were taking so far, because we were delivering tools to manage the systems, but they were based on IPMI protocol. The full software stack under Super Cloud Composer name is based on Redfish. So this is also a little bit different.
So this is how it looks like if you are having the racks. So actually you can also tag every single system. It's pretty easy to use. You can monitor your network. You can do plenty of stuff. So actually, I just want to go with few screenshots. So for example, to see how the CDU looks like, you know, and that we can monitor if the liquid cooled system is working properly, if the power is okay, pumps, and all this kind of stuff. We have also the sensor reading possibility, where we can also see if all the system are okay. In any case, if it's some kind of leakage detection, etc.
In short, it's the full telemetry of the unit. The same applies to systems which are being monitored.
And of course, we have the full history of data that you can also monitor very easily, you know. And yeah, as I told you, it's pretty easy tools to use, and it's also in heavy development still, you know. And we are also open if the customer wants to have, I don't know, third-part vendor hardware like different switches. We are implementing
or different servers even.
Or different servers. So actually the tool is completely open. And if you want to have some kind of reference links, there is also a very interesting YouTube channel. So our colleague Kevin is doing really great job, and he's posting, I don't know, every 2-3 days some new videos, what they are doing, how they are doing. So actually it's pretty interesting to check.
It's no marketing, it's academic style, so Kevin Kalp is really the man.
Yeah. And I would say this would be everything from our side for today. Thank you for hosting us. And if you have any questions, feel free to ask us now or just drop later, and we will be more than happy to answer on your questions.